So let's take a second to imagine what this world is like if it is indeed delivering, right? So in that world, it'd be easy to train data scientists. I don't think we can even agree what data science means, or AI, or machine learning, or deep learning. It'd be easy to hire data scientists. It's hard to say that with a straight face. I know it's probably harder to hire data scientists than to actually do data science. And we would be doing 1 to 2 dozen projects a year with a small data science team instead of 1, 2, or 3 projects a year. More of those projects would be successful than failures. And every company in the world would be powered by AI. No matter how medium size or small size, no matter how far away from Silicon Valley, it would just be everywhere. So if you still think AI is delivering today, you need to slow down on drinking that Kool-Aid. Because, I don't know if you can have an overdose of Kool-Aid, but you're about to find out. So I think being on the same page of everybody wants AI to deliver, and hopefully most of you agree it is not delivering yet. Hopefully most of you think it can deliver. So then the question becomes how and when. So I like this analogy. I think comparing AI to electricity is clever, is relevant, right? It's going to transform everything. I think every single industry in the world can be powered by it, just like everything can rely on electricity. That is why it is like electricity. I want to actually then dive into the ways and the reasons why it is not like electricity today. Right? So what are some of the problems? It's rare. It's hard to train these people, so they're hard to find, which means hiring is slow and making mistakes in hiring is frequent. And it's hard to hire if you're outside of a privileged company that can offer massive salaries or be doing something that's very exciting, right, and bleeding edge. It's slow. Very few projects get done per year. And because of the risk of a project not succeeding, right, the slowness combined with that means the number of successes you get per year can be quite small. I think it's also, actually no guarantee of performance, right? The last example, it's actually from a famous paper that compared baked goods with animals. Neural networks were confused between chihuahuas and blueberry muffins. I think there was also confusion between sloths and raisin scones. There's a lot of these little similarities between these things. On the slowness, I wanted to kind of touch upon a little touchy subject for some of the data scientists. I talk to a lot of data scientists. I mean, I've been a data scientist my whole life. And I talk to a lot of the product managers that work with data scientists. And it's really funny because when you ask a data scientist, what's the biggest problem? It's always data munging. They hate that. It's always the biggest problem. It's never model building. You ask the product manager or the project, whoever's managing them, and you ask them how much time they spent, tuning that model, and they always complain. There's this big disagreement there. And I suspect it's because tuning the models is fun, and they like to do it. Every data scientist, when I say, what if somebody automated that whole process, feature engineering, model selection, hyperparameter optimization, they say, well, that's not a problem. I can deliver a model in 2 days. Who here has ever seen a data scientist deliver a model in 2 days? Ever. Ever. Never. Right? Because usually what happens is a model gets delivered when somebody yells at the data scientist saying, please, give me what you have now. Stop trying to improve this thing. That's when the project ends. There's no end to it if that doesn't happen. So it is slow to actually get the best model possible. It's not a fast thing. Not realistically. There's cognitive dissonance there. Right? About the rarity. Data scientists are unicorns. They exist, but it's... Again, the amount of things that these people have to know is immense, which makes them unicorn, which then means, the idea that we're going to satisfy the supply and demand problem, which exists today, right? Massive demand for data scientists, or AI scientists, machine learning scientists, whatever you want to call them. And the quality and quantity of these people, there's a big problem there. Education will not solve this problem. You cannot mass produce unicorns. I don't care how hard you try, you cannot. You have to solve the problem by saying people that do this don't need to be unicorns, right? And coupled with education, of course. But education alone is not going to do it. The whole analogy with unicorns, I think, goes really well with the early days of aviation, which, these guys, right, the Wright brothers, they were the pilots. They were flying the planes. They were also the guys that built the planes, right? They were the unicorns of aviation. Imagine trying to build United Airlines back then. How do you say to yourself, you're going to train and hire 10,000 Wright brothers, right? It's preposterous. That's what we're trying to do today. So where we are with AI today, I think it's what has to happen to AI is the same thing that happened to aviation and a lot of these different fields, which is the field of aviation advanced to a point where the requirements for becoming a pilot were lowered, and then you can start mass producing pilots, and then you can have airlines, etc., right? So that's where we have to be, and what we have to do to AI today. It's advance the field itself to reduce the requirements of doing it. And then we can have this, right? We can have mass production of data scientists. We can have all the things we talked about, because now it's easier to hire, it's easier to train, it's easier to deliver, right? Data scientists can fear sometimes that a lot of this talk is related to them losing their jobs. It's job security. And it really isn't, right? The talk here is not about replacing data scientists. The talk is about how to optimize the value they bring to their companies. And with that, the actual job description will change. The set of skills that they have to learn will change, and where they focus their time will change, right? So they love turning knobs and tuning parameters. That is not the value they bring to their companies. If they think that's the value they bring to their companies, then companies that automate data science are not their worries, for losing their jobs, right? How they bring value to their companies is thinking up of ideas of how to use machine learning to improve the business, right? Formulating the questions, figuring out what data should be used, and figuring out new ways of using AI and machine learning to improve the business. That takes creative thinking. That will not be replaced by AI in decades to come. That level of creativity will be in the hands of humans for a while. And so that will be the job of the data scientist. No longer will be spending weeks and months just tuning parameters and looking at the little thing and watching 0.1% improvement because I tried these things last week and then I did it again and I saw it over and over and over and over, right? And some people get this. A lot of data scientists don't. It's not an easy thing to convince data scientists of. We were at, I met with a division of one of the top 3 biggest companies in the world 3 weeks ago. Their chief data scientist was excited about something that would automate a lot of their jobs, which was unconventional for a data scientist. We sent them a data set 1 week ahead of the meeting and said, you go and try to build a model, and then we'll meet with you in a week. And we did, and the CTO was in the meeting, and we uploaded the data set, and we had 90% accuracy in 10 minutes, and the guy said, well, in 1 week I got 73% accuracy. The CTO wasn't impressed at all and said, oh, that's bullshit. You chose the data set, this means nothing to me. And I said, fine. And they said, why don't we upload a data set of ours right now in front of you? And, quite a few people in the room got a little nervous and sweaty. And my COO was, a little, oh man, this is happening. I was like, yeah, this sounds like fun. Let's do it. So they did it. And they said, look, it took us 2 months tuning this thing to get to 93% accuracy. And it was one of those things where the data scientist said, well, I can do it in 1 week, but, let me get it a little better. And it ended up lasting for 2 months. And we waited for 15 minutes, and we got to 93.3% accuracy. And, they were sold. They ended up buying the product. But most importantly, I'm not talking really about the technology here. I'm talking about the cultural reaction, right? The data scientist, the chief data scientist that was in the room was marveled. He was happy because he said, look, I'm the chief data scientist. I have 7 data scientists. I'm the only guy in the company thinking about how to use AI to improve the business. I'm thinking up of all these ideas and coming up with these projects. These 7 guys are executing. And he said, I see the value in what I'm doing. I don't see the value in what they're doing. If we can get software to replace that, now I can have those 7 guys do the same level of thinking that I'm doing. And now they, all 7, are 7 of me's, bringing the real value to the company. And that's why he got excited, right? He saw the future, the change of the task of the data scientist. And it's going to take time, but I'm completely convinced 3 to 5 years from now, not a single data scientist in the world is going to be building models by hand, unless it's for academic or research purposes. It just doesn't make sense, right? People that know deep learning, they're experts. If if you think only 10% of data scientists are real data scientists, and of that 10%, only 10% do deep learning, of that 10% of 10%, only 1% really knows deep learning deeply. Those are the guys applying deep learning to advertisement, to image, video, car driving themselves. It's like a pilot having to know how to build a jet engine. The only people that should know how to build a jet engine are people building the next generation of jet engines, right? A guy that's applying deep learning to anything should be like a pilot. The only people that should know that much deep learning are the people building the next generation of deep learning. So why it isn't electricity, right? Electricity is easy. Electricity is cheap. Electricity is ubiquitous. AI is none of those three things, not one. That's what makes electricity amazing. And this is where the comparisons fail, right? Easy, cheap, ubiquitous. Those are very important things for anything that needs to be transformative in the world. They have to be these things. If it's not going to transform anything, right? So we're obviously not there, right? It is not easy to train or hire data scientists, right? It's not cheap. It can be cheap, right? The idea of having projects that are done in a matter of days instead of months, right? That would make it cheap, even in the sense of risk, because if it fails, it fails. It failed in a week of time. It didn't fail after 3 or 4 months of some guy turning something. And a lot of times it's not the problem, right? You're left with this question of, why did the project fail? Did I not hire the right guy? Did he not try the right algorithms? Maybe I didn't have enough data. Maybe the data wasn't clean enough. Maybe it's not a predictable problem. You could have the best data scientist in the world and have him try to predict, lottery numbers based on the colors of the rainbow. I don't think he's going to do it. I don't care how good that data scientist is. Some problems are just not predictable. That one is pretty obvious that it's not predictable. Some are not. Some you just don't know until you try. But if you are not confident in the quality of the people you hired, you have this question of, should I try this project again with better people? Or should I believe that this problem is not doable unless we do something about it? And then that really drives up the cost and the risk of these projects, right? And then ubiquitous. I think once it becomes cheap and easy, then ubiquitous is the logical next step, right? Where it's actually everywhere. Which brings me to this, right? I've seen this asked at this conference many times, and almost every conference I go to, it's always, what's the next 2 years? What's the next 5 years? What's the next 10 years? What's the next big thing from AI? Right? This is how well we can predict things. These are quotes from people in those fields before these things were easy, cheap, and ubiquitous, right? The telephone has too many shortcomings to be seriously considered as a means of communication. The device is inherently of no value to us, right? The airplane, not military value, just none, right? Same thing about computer, everything. It wasn't until those things became easy, cheap, and ubiquitous that we started letting our imaginations fly and applying it everywhere. So anytime somebody asks me today, what is the next big thing with AI? I honestly believe the right answer is we have no idea. We always like to think we know everything, and we say, well, it's going to be this and this and this. But no, this is what we're saying right now. 10 years from now, we're going to be looking at the quotes of today saying what AI is going to do. It's going to sound like that, because AI is not easy, cheap, and ubiquitous. And without that, we just have blinders on that prevent us from seeing the real impact it can have, because we're so focused on, oh, but it's so expensive and it takes so long and I need to hire an expert. It doesn't allows our imaginations to fly, right? So my answer is not really an answer. It's saying we don't have the answer, but this is the reason why. I think, the whole idea, right, of easy, cheap, ubiquitous is turning the world from that with electricity with respect to AI into this, right? It's, what if nobody had to worry about execution anymore, right, in order to get AI? What if the only barrier between your company and the AI, the value AI can bring, was your imagination, right? That's what I'm looking at. It's, if you can imagine it, AI is going to deliver it. And I think it can. And that's what drove me to start Opal. It's this idea that it should be that easy. It should be, if you can imagine it, AI is going to deliver it. So I purposely ended this nice and quickly. I wanted to talk mostly about high vision, high level vision of where I think AI is, where I think we're going, and what I think needs to be done for AI to deliver on its promises, because the bill will come due and AI better pay. right? Right now, at most companies, the board members say, why don't we have AI? And then they spend a year hiring an AI team. And then for the next 2 years, they say, we've got AI. What is AI doing? We've got AI. What is it doing? We've got it. So at some point, though, you have to stop saying just we've got it, and it's actually got to show some value. So if there are any questions, I'd be happy to also talk about technology, which I haven't really talked about, or just anything about AI. Questions?
Hi, thank you for the talk. My name is Guy. I went to a couple of months ago a talk about with people from IBM and Google and talking about all those issues, and they were saying that another big problem in AI is that in fact it's not very transparent, and that you don't really have the tools to understand and to clearly map out the changes that you are making to algorithm or to models, And so it seems that, you need the data scientists to think bigger and not to be, in fact, what you're describing as data engineers. They are not really data scientists they are looking at. But you also need the tools to be able to understand, the change that you make and to create more transparency into the system.
Yeah, it's a very good point. There's a fantastic paper from, I think, January of this year, and it shows that it's the transparency of what the models are doing. It proved a very strong point. Everybody's familiar with ImageNet and how well ImageNet models do. I think they used ImageNet on purpose as an example of why we need model explainability, right? In human readable terms. Not, oh yeah, it's multiplying these two numbers and it's adding this and here's the layer of 17. And they looked at the differences between a Siberian Husky and a wolf. They're very similar animals. And the model that was the ImageNet winner at the time could, I think, almost perfectly separate wolves from Siberian Huskies. They looked at which pixels had the highest value when you backpropagate through the network to see what are the pixels that's actually telling this network this is a wolf versus this is a Siberian Husky. 0 pixels on the animals. If the background had snow, it was a husky. If it was woods, it was a wolf. So what happens when that animal's crossing a street? What happens when that animal's in a vet clinic? There's no idea. That model did not learn the difference between a husky and a wolf, right? It looked like it did because the training set and the test set both had that bias. So it looks like, oh yeah, it's not overfitting. It's fitting perfectly to the separate test set. Well, the whole data set was kind of overfit to a specific case. That highlights the point of, one thing that we're doing, which is developing technology of once this model is built, how can we explain it in a human readable document that says, here's some examples of why it's making these decisions, right? It's never going to be super specific. It can be by being probed by a scientist, but it's going to be at least a starting point of, here's the most general cases of why I'm predicting A, B, and C. And you can start probing the system saying, this particular one, why did you predict it this way? Show me why. And so that is important for people to feel comfortable that the models are not making silly mistakes like the one with the wolf and Siberian Husky. Good question. Any others? Yep.
Is your service industry focused too?
Yes, the industry of AI.
So financial.
Yeah, I mean, we've had customers, manufacturing, insurance, fraud detection, online gaming, lung cancer detection, I think like 10 different industries. It's my belief that if a Kagler can successfully beat domain experts at every single thing they do, then so can a machine if you train it right. It's something that makes me think of one of the technologies, which is learning to learn, which sounds kind of absurd. If you're familiar out there with the learning to learn papers from Google, it's basically hyperparameter optimization. What is it that the human brain is learning when it's doing that? What is the metadata that your brain is actually processing that allows you to learn? Then you can formulate the problem. And if you can formulate the problem, you can actually train the machine to do it, to learn. So then every project that it touches, it gets better so that it can apply its learnings to the next one, independent of what industry it is. Any more? Nope. All right. Thank you.